All right. Hello, everyone. My name is Marcelo Bardos. I'm the CTO and founder of Herodotus. So maybe to start, a few words on Herodotus. So we have been building ZK infrastructure for the last 4 years, more specifically around a primitive called storage proofs and ZK co-processing. So provability is deeply into our DNA, verifiability and privacy. And recently we saw that there is a lot of issues ongoing in DeFi, and I would say the most widely accessible product is Vault, because running different strategies just like is not something trivial, and like users tend to delegate those things. But when you delegate, some other problems appear, right? Like such as, do you trust the curator? Do you trust the Vault operator? And I think that historically, in the last cycle, we've seen those things blow up. So we are on a mission right now to bring visibility and more transparency to Vaults. And well, something I think we really stand for is like, trust me isn't an answer. So we want to bring verifiability again. However, it's not like black and white in the case of Vaults. Because like if you actually look into them these days, a lot of this yield like is not native on-chain. Like it doesn't come just from running a strategy on-chain. So there's a lot of off-chain components. So what I want to say by that is that it's not black and white. Like you cannot prove absolutely everything with like either storage proofs or ZK. Like there is some trade-offs you have to make, and I want to like talk about it. So one thing is like transparency, which is something that LPs will seek. LPs is like you are just a regular person, you deposit money into a vault, and you pretty much would like to understand like what's happening with your money, how it's being deployed, to what level it's being leveraged, and so on. You would like to have some visibility, and ideally you don't want to audit those things yourself. You just want to know that it sits within some risk parameters. But then you have on the other hand, you have the operator, the manager of that vault, who, if he's running some sophisticated strategy, like he wants to keep the alpha, and he doesn't want to reveal everything on-chain, even like implement the smart contracts to like actually execute the strategy. Like usually you just delegate those things. So there's also like this issue, that not everything is meant to be revealed. And we think that ZK is really a good technology to like bridge that gap. Because on one hand, you get verifiability, like I don't need to show you all of the data to prove something about it. That's the idea behind ZK, so you can, be transparent, but don't reveal everything, which is, I think, an amazing property that can be leveraged specifically in that problem area. All right, so what I envision is that whenever funds are being managed by Vault, like the auditing process shouldn't be that, every so often we just publish a PDF and we call it like visibility, how it's called, like a visibility report. Does anyone remember? I just forgot the name. The human brain on cortisol like tends to forget some names. Transparency report, oh yes. Just, we publish transparency reports every so often, like, cool. Is anyone actually reading that? Maybe if I have a lot of money into a vault. If I disagree with something, can I do something about it? Well, in the best case, I can withdraw funds from the vault. And what I really think and I vibe with in this whole cypherpunk vision is that there is just a continuous proof that we keep posting on chain, and we prove that, hey, as a manager, I'm not leveraged. I'm not rehypothecating this collateral, this funds, etc. And if I am, let's say, underwriting or running some strategy, like it's not crazy. And that also, applies to some extent to like off-chain stuff, because we don't need to prove anything. Like we just maybe care about how leveraged you are, right? So, yeah. All right. So I think that the three fundamental questions that we should take into account when we actually audit a vault in real time is, can I repay? Can it repay? Basically, if I want to withdraw, like, is there funds that can be somewhat redeemed? Where is the money? What we're exposed to? And is whatever assets we have, like, what's the worth of it? So I think it can be broken down into like many different aspects. But what it really comes down to, like either the strategy is like fully on-chain or has some off-chain elements, is how you manage risk. And I think this is really the tricky part because it comes with a lot of computation. You don't want to reveal the full strategy. There's a lot of data components because some data lives on-chain. Okay, we can prove it with like storage rules and stuff, but some data lives off-chain. So how can we deal with that? And then there is the other aspect, which is computation. Very often when I run my risk models, like I want to do, let's say, some Monte Carlo stuff or like some Garch, which is massive. Like, how do you even prove those things? And that's what I really want to talk about today and sort of give you the problem that you're actually trying to solve. How you can, again, verify vaults. And that verifiability comes from how do you verify data, what you actually care about, because you don't want to verify the full life cycle of funds being deployed, because why would you? And then the other aspect is like computation and risk. Let's add some more complicated stuff to it. Very often these days, you have strategies that rebase, let's say, things on-chain. You have multiple venues, so let's take as an example, let's say basis trades. You can do it on like multiple perps venues, right? So you have data coming from absolutely everywhere. You need to normalize it, so you know it's problematic. And also you do it over time. Why over time? Because, for example, as an operator, you would like to prove that, hey, not only I have some strategy and this is the historical claim, effectiveness, but maybe you even backtested it with your risk engine and you want to prove that, hey, according to my backtest, this is the actual performance. So again, the topic is really complex and we are not going to give you the full solution for it, but there is some aspect into this like problem space that can be addressed today, and that's my main message I want to convey today. So let's talk about, let me move to this one. Okay, this is the part I really like, and I hope you guys get engaged. So, risk is a big topic today, and it's made of a couple of things. First is, let's say, counterparty risk, like smart contract risk as well, but then there is also like quantitative risk. And what you can model is quantitative risk because it's about numbers, right, not the counterparty. And when you deal with numbers, like usually you are gonna use some pretty sophisticated models if you're a sophisticated operator that has like a, let's say a higher yield than usual, but it comes with risk. Anyways, what I wanna say here is that you might use a pretty sophisticated mathematical toolkit, such as Monte Carlo simulations, Garch, etc., which are pretty heavy operations to do, to prove with ZK. And you know, we've been thinking about it like quite a lot, how you actually prove these amounts of computations that often change even, and that's tricky. And even when you do it on like, let's say a CPU and you have a vault that is, let's say underwriting some loans and responding to RFQ, like even doing on a CPU, it's hard. So if you have to generate proofs in real time, that is absolutely crazy. Like it's not viable, you're not gonna do it. So what we thought that, hey, maybe we can try to break down the problem. And I'm happy to talk about it like afterwards, like in questions, because it's a really huge topic that I cannot cover in like 10 minutes. But basically what we came up with is that we built a system of like kernels. So kernels are basically some simplifications of the problem. So imagine you have like a multi-dimensional space where you put a lot of like things into there. You run a bunch of like Monte Carlo simulations or like whatever. And we're just gonna generate some, again, I missed the word, let me just remind it, what I wanted to say, some derivatives from that. We're just gonna generate some derivatives, some mathematical derivatives, and commit them on chain, build a tree and stuff like that. And that way you basically build a really efficient lookup table. And from this lookup table, you're able to like respond very fast, and you do quite simple math. And that way you make those things provable to some extent. And what is the nice property of that? That when you generate these like huge lookup tables, you might or not prove that, but you just commit it to once, and then every time you reapply some changes to your model, you can just prove that, hey, it's still a transformation of the original lookup, and I'm not changing the rules. So if you commit to some, let's say, risk engine, some model, like you can prove that you're not changing the rules, which I think is quite nice. And then, on top of that, you can have some basic constraints that every time I'm deploying funds, I'm proving that I'm not taking as collateral or I'm not exposed to something that has a volatility higher than like 60% a year, or I'm not overexposed to one specific asset. You know, like these are like simpler things to prove, but what we're working on, and I would really love to talk about like afterwards, is that we basically managed to like narrow this down to, you know, a simple problem, and once it just becomes like arithmetic, you can just prove it, and you can do it quite efficiently. And vaults can actually follow this, and every time we deploy funds from a vault, we just provide a very simple proof, and those things become viable. So what you get in the end is provable pricing, which I think is awesome because we can, let's say, underwrite loans efficiently, but also in a secure way. And it doesn't become a black box at the end. I think that's it from the overall topic. Happy to take questions, maybe as a call to action. What I'm gonna say is that I am Marcello from Herodotus. We've been working on like ZK coprocessors. We built a ZK coprocessor. You can reach out to me on Telegram, and there is actually one product that we're building on top of our stack. It's called Dialog.xyz. It's a prime brokerage solution where we have to deal with risk. We do underwriting and we prove those things. So if you're interested in like looking into the details, how it actually works, check out the docs. And also I invite you to like, you know, talk to us if building provable vaults is something you vibe with. Thank you.
Question. So could you elaborate a little bit on the problem definition? Because I get all this like ZK stuff, but I didn't get what the problem was solving. I mean, like we have a vault, for example, and we have some kind of a risk score for that vault. Why do we even like need a ZK?
So let's say Oh yeah, so what the question was about the actual definition of the problem, because you know, on one hand, you have, let's say, risk defined by just a score of, let's say, a protocol. But what I talking specifically about is like the quantitative risk. So how, as an operator, I can prove that I'm, let's say, not overexposed to one asset. If my strategy is about deploying, I don't know, maybe to some, let's say, basis trade, like I want to prove that if something blows up there, it's not going to erase my entire portfolio. So it's really about like, what is my confidence and what is the probability I'm going to get absolutely wiped out? And, you know, there's like many variables into account, such as volatility of the collateral, maybe some on-chain liquidity. If shit happens and I need to run liquidations on-chain, historically, was there on-chain liquidity? And if not, were there liquidators actually buying those stuff, you know? So a lot of historical data and like numerical data you have to look into. And that's basically, you know, the problem we're trying to solve here. Just like more quantitative risk. Any more questions? Okay, no more questions, so thank you again so much. And yeah, just, you know, Marcello_NJMI, docs.dialog.xyz, thank you.